Yes, let's talk about Cortina this time. More precisely, I'm going to start with a video on how you can apply the coroutine if you use the SciPLEPL 14 version, but rather than focusing on the specific implementation method in the first video. Let's go over the basic principles of Coroutine first. Why did you need to use Cortina? First of all, let me tell you about the background. First of all, our company switched the legacy startup project based on Unity to our own engine and $10 based engine. There was a change that had to be made, that was to be made. But our shop basically has a coroutine function. However, because our engine was based on CPLPL 14, there was no built-in function called coroutine. So the function's tailored to coroutine in C#. It should have been added, and for this purpose, we implemented the CIPLP14 based coroutine function. Now, first of all, I'm going to talk about what this coroutine is, but before that, I need to talk about this concurrence. We usually talk about simultaneity. In other words, coroutine is to satisfy this simultaneity. This is a concept introduced to achieve the goal of simultaneity. What is simultaneity at this time is that multiple tasks are executed at the same time, and then in the middle of executing this task, I switch the task only when it is put into I/O state or makes a network request. Do it. In other cases, you can think of it as always performing tasks without exception. So we have a couple of ways to implement this, and the first one is going to be multiprocessing. Simply put, if we have multiple tasks, if we have 3 tasks called ABC, as shown in the picture, make the process that acts on his behalf into 1, 2, 3. So each process keeps each desk working. But there is a downside to this multiprocess. First of all, memory usage must be high, because each process allocates separate memory space in the OS. The memory space that needs to be used increases accordingly. And then these memories, the memories of each process, are all independent. This means that in order to communicate between Nixon processes, we have to communicate using the concept of pipes in terms of windows. But this is not as simple and cumbersome as we think, so communication between these different processes is difficult. So, one of the alternatives to this is multi-threading. So multi-threaded is not like we did above, but instead we create the concept of this thread with only a separate step memory space within one process, so that each thread can execute different tasks by taking an independent execution unit. Now, there are advantages over multiprocessing, right? Of course, as I said, each person has only this stack memory space, and what else? It shares space in processes such as code area, memory space, heap space. That means we have less memory to use than this multiprocessing and then earlier. In multiprocessors, communication between processes is difficult. Because it is an independent memory space, it was said that you should use a pipe device to communicate. But what is actually assigned to this process between these threads? The heap space data space is shared. Then, communication is relatively simple because you just need to communicate through the shared space and shared memory. Now, isn't multi-thread read enough? You can say that, but this does not completely achieve the goal of simultaneity that I mentioned at the beginning. Let's look at the purpose of automaticity one more time. You have to execute multiple tasks at the same time, so you always have to execute them. I always mean well, if you make an I/O request or a network request, it will be locked and unable to perform that task for a while, right? Except in these cases, it should always be done. So let's say that 3.1 runs a 3.2 runs a desk B and 3.3 runs a desk C. Okay then. Thread 1 is ready. Thread 2 is running. Now it takes the resources of the CPU and is actually running. Thread 2 is not realized because thread 1 is just waiting. Let's assume that thread 3 is in a blocking state because it has been blocked. Now, what is thread 2 working on? Is it okay because I'm running by task? Same with 3. Because I made an IU request. He should not be able to work for a while. But what is A? Now, what is this Lido one? I didn't even make an IO request. In other cases, should I not always have to execute 2A? Desk A must always run, and it is now based on this schedule that is due to an external factor called scheduling. Even though it is a task that needs to be executed, it cannot be executed now. That's why it's not perfect. So the concept that came out to complement this is the concept of Coroutine. Basically, Coroutine has a concept called ILDE. What I mean is that I will only work until a certain point and then hand over some of my executive authority. So Coroutine now has a thread like this. So we run multiple threads sequentially like this. So you're actually doing multiple tasks at the same time. I'll do it sequentially, but I'll always do it afterwards. As before, when we say that each task is performed through a different thread, what is the thread? You said that if you put it in the ready state, it cannot be executed. That's a little bit against the purpose of simultaneity, but in fact this sled just does it all the time. These tasks are just always executed. Now, so what's really fascinating about coroutines is, for example, let's say we have a function called hello rather than a, then sleep. Execute this part and transfer ownership. Then, if you run hello again, it will start from this part instead of here. If you do something else, then you will execute it in this part. Then look, what if I made an IU request here? Then you do things and let other desks run. Then, when I enter hello again, by entering here, this hello task will always be executed in other parts other times, except for the state I requested. So with this concept, you can think that there is now a coroutine.